water. So what is a capacitor? So this is a classic example of a capacitor. We want to draw the symbol. Circuit diagram is like this. Capacitor of capacitance C. This is the circuit diagram. Now that I'm talking about capacitance, let's get there. So capacitance means charge stored in the capacitor per unit voltage or potential difference across the capacitor plates. So you can note this down.
So for charge, it's Coulomb, right?
Yes, sir. Oh my God, this is so pathetic. You can note that down.
Yes, sir, you can continue. Sir, 5 microfarad.
Okay. Capacitor has two parallel plates. The placed on top of each other, connected to a battery somewhere. Now, you might want to know what is the capacitance of a parallel plate capacitor. So this is the first important part of this chapter. So capacitance of parallel plate capacitor, how will we find? Let's take a look. So first of all, we need to understand that how does the capacitor look? So we can draw something like this, horizontal or vertical. This one has plus Q, this one has minus Q. And field inside is E from plus to minus. E is equal to sigma by epsilon naught, where sigma is charge upon area of plate. Area of plate is A each. So we know C equal to Q by V, and this implies V equal to ED is equal to QD A by epsilon naught, where D is the distance. This is the relation between electric field and potential that we have studied earlier. You remember?
Yes, sir.
What is the relation between field and potential? If it is uniform electric field, then distance into field is equal to potential difference. So C is equal to Q by V. So Q by Q D by A epsilon naught. That's A epsilon naught by D. That's the famous formula, C equal to A epsilon naught by D for the capacitance. But mind you, this is only for the parallel plate capacitor and not for other capacitors. I have a couple of questions for you. Make it loose, jamba juice, na na na. That's the first question. The second question is, that's the second question. How do you like the questions? I have a third question also. What you gonna buy? What you know about rolling down in the deep when your brain goes numb? You can call him any freeze. Here's your second question. What you know about rolling? What you know about rolling down in the deep when your brain goes numb? You can call him any freeze. Okay, there you go. 2 questions for my friend. I think that should be good enough. Also, I'll just separate them a little. A spherical capacitor consists of 2 conducting hollow concentric spheres with, of course, different radii, but equal and opposite charge on each. So this one has, let's say, plus Q on it, and this one will have minus Q on it. The capacitance, let's call this radius R1 and the other one R2. Capacitance is given by the simple formula 4 pi epsilon naught R1 R2 by R2 minus R1. That's all you need to know. So you can look at it when you apply in a question that there is a formula for capacitance. Cylindrical capacitor. Same story. 2 conducting concentric cylinders. Different radii, of course. Radii being R1 and R2. Charge being plus Q and minus Q. Capacitance being 2 pi epsilon naught L ln R2 by R1, where L is the length of the capacitor. Let's do a question on this. Good question. It is 11, 11, 11, 12. Let's do question number 11.